Okay, everybody, welcome to Infrakit webinar, Digital Infra Construction. Today we have 3 hours of really good presentations, and we have divided the session to 2 parts. First, we have 3 presentations, then we have a 15-minute break, and after that we continue with 3 presentations. After each presentation, we will have a 15-minute booked for discussions, so feel free to ask questions. My name is Toni Lahtinen. I'm Vice President of Sales at Infrakit. And before we go to the presentations, Teemu Kivimäki, founder and CEO of the company, will start with opening words. Welcome, Teemu, please.
Thank you, Toni. So let me bring up. I wanted to present Infrakit as a group, a little bit where we are today as a company, and let me share my screen. Infrakit, a digital transformation partner. We are looking to partner with the most innovative construction companies in the world. The company was founded originally in 2010 from university research. I was working as a research scientist at the Oulu University of Technology on construction automation. Today we are 41 employees, and last year's revenue was about 3.5. We have 8 offices in Europe, and our customers include the largest Nordic construction companies as well as infra owners. And what I'm very proud of is the development of the company. In the last 5 years, we have grown over 10 times in size, and the direction is up. We're only in the beginning of the journey. And there have already been over 2,000 projects in 10 different countries built with Infrakit, and over $30 billion worth of assets have been built with Infrakit. Very successful projects. What I'm especially proud of is the success our customers have had especially in the Nordic markets. There are many large projects that have really been completed or even a year ahead of schedule, and millions below budget. For example, Tampere City Tram first phase was completed 26 million below the original estimated budget, and E6 Arnquell in Norway highway project was actually completed nearly 1 year ahead of schedule. So now you might ask, how is this possible? What's behind this success of these construction projects? And it's a concept called model-based construction. So basically having very accurate designs done as BIM model, and then using that design to actually implement the construction works in the field. So Infrakit is integrating the different design fields and then offering a real-time situational awareness picture from the site, where the different machines are, where the trucks are, what they are doing, what they have done in the last week, and or during the project. And there's always quality report being continuously produced. We are also integrating drone ortho photos, point clouds. We are offering all the and all this information is available on mobile devices, and also we are integrating now. The latest addition is the professional surveying tools, and today we have our good partner, latest integration partner, Leica Geosystems, presenting surveying equipment integration that has been added during this winter. So without further ado, I'd like to let us our customers to present their cases. First up, we have a railway construction project with Katja Krag from Switzerland. And so Katja, please feel free. Thank you.
So hello everybody. So thank you first of all for the introduction, Teemu. So yeah, my name is Katja Krag. I'm working at Sersa Group AG, I have to say. And I will tell you a little bit about the railway construction sites with Infrakit here in Switzerland. And we started approximately, the first pilot was now 1.5 years ago, something like this. And yeah, I will go into that later. So, first of all, who are we? The Sersa Group AG, how we are organized, and afterwards a short introduction about the railway itself in Switzerland. And I like to give a short overview about our equipment we are using. And then I also like to show you some of our construction sites, also inside Infrakit, what we are doing there. So who is the Sersa Group AG Switzerland? We are a part of the Romberg Sersa Rail Group, which is based in Bregenz, Austria. And Romberg was founded in 1886, and actually we have approximately 2,500 employees in 7 countries on 3 continents, which you can see there: Austria, Switzerland, Germany, UK, Ireland, Australia, and Canada. I have to say, all these countries, they have different approaches in their markets and also different business cases as well. And worldwide, also, we are talking about more than 200 rail-bound vehicles. So, So this group in Switzerland is, we have different brandings running here. One is the branding Sersa, which contains the SGS, the Sersa Group, and the SMG, which is Sersa Maschineller Gleisbau. So they go more for the machines and all that stuff. And then we have also the company Donach, but they are producing steel and it's coming from the steel side. We have approximately 1,200 employees only in Switzerland and approximately 100 rail-bound vehicles here in Switzerland. Our main customers are the SBB, which is the Swiss railway company. And for example, also we have the Rätische Bahn, which is, some of you may know the Bernina Express, for example, which is famous for their scenes and so on. What are we doing there? We are having new projects. They are very seldom here in Switzerland, but we have a lot of renewal, maintenance, and renovation and so on. So what kind of tracks do we have there? We have one hand, we have slab tracks, which means you're running the rail on concrete surface. and we have the ballasted tracks. And here in Switzerland, it's normally that the tunnels are only slab tracks and the rest is ballasted. So, and another thing we have here in Switzerland is the SBB. They go for the normal gauge, which is called Normalspur here. The width of that is 1.43 meters. And in addition, we have, for example, the Rätische Bahn or the Zentralbahn as well, which is another one. They have a narrow gauge, which is only 1 meter width. So we have to deal also with different input of our data. As well, we have a system here in Switzerland, TopoRail, which is operated by the SBB. I will show it a little bit later what's in there. It contains the whole railway network here in Switzerland with all very detailed information, but you cannot always rely on that. So, and also actually, because of these different gauges, we have also railway stations where 2 gauges go into one. So then it starts challenging on all that stuff. That's something you just have to keep in mind. So what kind of equipment do we have here in Switzerland? So we have one of these small compact track loaders, the Case TV 380. This one is equipped with a Leica system, the MC1. It can run either on GNSS or on total station. As well, we have 2 Leica excavators, the LH922. This one is the wheeled one, but we also have one which are running on tracks. And as you can see down here in the picture, we have this part here goes into the rail. So these excavators, they can run either on the rail or on the surface. So, and you need to have special licenses to drive these machines, which you could imagine. So we have 2 of the wheeled ones, and as well we have the Leica Icon series, the GNSS, which you can see here very small on the picture. On the left-hand side, also to do the as-built checks, for example, or in this case, this machine is not equipped, so then they go with the GPS and do the as-built checks and tell them, hey, you have to go higher or deeper. So the short overview about all our equipment is, as I mentioned, we have the compact track loader with the Leica system. We have 2 wheeled sleeper excavators with mobile Novatron system. We have 2 tracked sleeper excavators with a mobile Novatron. And we have a small Wacker Neuson excavator, also with a Novatron system on it. And we have another excavator, also a Leica 922 with a Leica system with GNSS on it. So all the excavators are only running with GNSS. And we have 4 excavators, which are Caterpillar. They will be installed during the next 6 months, I would say. One is still in the factory, but the other ones are already operating out in the field. As well, we have a milling machine, a Wirtgen W200H, and this one is also equipped with a Leica system, can either run with GNSS or total station. And then we have our famous W Plus machine. That's a special machine. That's somehow own development, I have to say. So the full steering of the 2D is coming from our colleagues. And the 3D part is done by an external company. But using from the sensor sides, we have the GNSS or the total station from Leica, as well the Icon series. In addition, actually, we have 4 Leica Icon total stations and 6 Leica Icon GNSS, and they are running somewhere in Switzerland, all that equipment. So that's also something you have to keep in mind. We have all these machines and they go from A to B very fast sometimes. So coming now, where do we get our data from? We have the TopoRail, as I mentioned. As you can see on the right-hand side, we have all this information there, and you see the overview of the network of the railway here in Switzerland. Almost everything is inside except some smaller running companies which are not necessarily in there. It maybe also not so detailed. So what kind of information do we get in there or out there for us? mainly we use for the modeling for the machine control and so on. And Infrakit, we need the axis, we need the fixed points, and we do a background map out of that data. So the axis, that's already the tricky part on it, because it could be both inside, which means the old one, but it could also be at the same spot a new one, because sometimes they are moving the axis in X, Y, and or Z direction. So, and the fixed points, you have to know in Switzerland, normally at each catenary mast of the railway, there is a fixed point, which is a standard Leica bolt where you can hook on a Leica bolt. And this is always got a 3D information in X, Y, Z direction. The background map, we get more detailed information there, and we do not anything with the data itself. It's just for the drivers and operators to have a rough orientation where they are. So now we only have the axis, but we want to have a model. We need a model for the machine control. And as you can see, that's what we get, the so-called Deckenbuch. It contains the information of all the cross sections. Funnily, I took the Italian version now in this case. That's also another issue here in Switzerland. We have 3 languages, French, German, and Italian. So it could also happen that you get data in another language, I would say. So that's the basic information you get. In Switzerland, that's also typical here. We have the axis, which is this point G here. And depending on that, that's the rotating point to change the height and everything for the profile. So it's not the left or right rail. As well, in this Deckenbuch here, you get the information on the sleeper itself, if it's concrete, wood, or steel. And depending on this one, we create the surface for the ballast, because you need to have the delta height there as well properly. So now we have inside our BIM team, we have some modelers, and they are creating these different layers. So as mentioned, we have the axis information coming from Topo Rail with the fixed points. They're not doing anything. They only convert it to land XML because it's the own format they have. And they have the background, the cross sections, sorry, and information. And the background map also will be cleaned and converted to a proper file that it can be used on the machines. It's more like, too much information, and you cannot see things properly. So it's depending also on colors and all these things. So the output from the data modelers is still we have the axis, which will then be land XML format or DXF, one of these. Preferable, we like to go for the land XML. So this axis will also be converted during that time. As well, the fixed points, as I mentioned, and also the background map is cleaned. So, but we need the layers. So what we do is, as you can see here, B3 is the top of the rail itself. The B2 is the sleeper, so which could either be wood, concrete, or steel, for example. And then they have to define this layer B1, which is the ballast layer. So out of that one, you get the subgrade layer, and so up and down. So that's done by our modelers in the BIM team or somebody out of the surveying department we have as well. So what's our workflow in our context is, first I create the project with our special file structure we just defined and add users to the project. Then I copy all the data to the desired project in Infrakit. So which are the axes, fixed points, surfaces, clean background map, and also PDFs, which can contain some plans and informations. And afterwards, I check if all data is available and can be read and is also shown in Infrakit, because sometimes we have issues that during all this process, we have a file which cannot be shown or so. So, and then as well, I do a first check if the data or model makes sense. If yes, then I can notify the foreman, and then he will continue to do the final check. if no, which means the model doesn't make any sense, then yeah, we have to talk to our customers, SBB, for example. What can we do? Regarding to the file structure, that's only an extract, which I mentioned now. So we also take pictures with a mobile phone. We also take pictures with a 360-degree cameras. We also have the documents in addition, like we can put in some manuals, for example, and so on. And we also collect the as-built points in there. So what kind of challenges do we have? You have to keep in mind that normally we have very short notifications to get the model done, but we are educating right now our foremans and so on, and the construction team, that we need this 6 weeks ahead before they start the job site. So actually we have two bigger projects. One is called the Weichenlos, which is for the SBB. So that contains renewal of turnouts in Switzerland during the next 2 to 3 years actually, but it may be extended to 25 as well. And another big one project, or bigger ones, which is not typical for us here in Switzerland anymore, is it's the Doppelspur. That's what I mentioned here, is because we have two gauges which go into the main station in Luzern. So that's Doppelspureinführung, it's called in German. And that's for the Zentralbahn, which is a smaller company which are running in the center of Switzerland. So this Luzern project is a longer project, and we have there a lot of involved companies. So, and they are not using Infrakit, I have to say. And for example, this Weichenlos project, as I mentioned, they contain a lot of small projects inside, and they are then very short. So you exchange one turnout, which means you need to cut the rail, then you take off the rail, you take off the ballast, and then you have to put in everything new to the new position. So this could be either a night shift or a weekend. So at the end, it's a lot of time pressure. So I was on one job site 2 weeks ago or 3 weeks ago, and they have to finish in a one night shift until 5 o'clock in the morning. Otherwise, they have to pay a penalty. In this case, I guess it was about 50,000 Swiss francs for each hour they delay, because it's one of the main routes which go to Zurich Airport. So yeah, everything needs to go there, and there's always a plan B in the background. Another challenge is, where do I get base data from? For example, TopoRail, SBB, and so on. Exactly the case, model issues. This Deckenbuch sometimes contains data which is not as it should be, for example. And also then we have the issue, who agrees when we have to change something and want to build that. That normally has to go back to SBB, and this is why we need approximately, or we like to have the 6 weeks in advance, because then sometimes inside SBB, for example, they also start a process. What do we do there? And as mentioned, in this night shift job site where I was, the reality looks different. What do you do then? Who's making decisions at the job site? In this case, they found some concrete underneath, and then they started a discussion if they can put the sleeper on that, because it was a concrete sleeper, and then it could easily break. So, and then afterwards, yeah, you have to fake who's responsible for that. So, and as well, what we do is we do the as-built data collection. So I like to show a little bit inside Infrakit itself on some projects. So that's one of the SBB cargo projects where they had to renew 3, 4 turnouts. Unfortunately, on this project, the access not available anymore. But as you can see in the background a little bit, you can see the railway it's going. So we have this project here, which is the ballast, the top of the ballast. And you also have these small boxes in here, and these are the turnout switches. So we created a model for, so the excavator can also dig deeper there. I can show you some pictures here. Which one was it? So we go for this one first. So as you can see, this one goes lower. The issue is they put in the engine here again, and then the ballast at the end is being one surface. So, and I guess it was this one. So you can see properly it's only this part, and here this normally the rail goes continuously through. So, and as well as I said, we do this for the cross checks, for example. I'm not doing this in this project. I changed the project now to another cargo job site, which is close to Zurich. And here you can see as well, the project is already much more complicated. So this machine, this job site was done with our W Plus machine. And this machine can remove the ballast, and it's cleaning the ballast inside the machine and puts it directly back in. So it's one step, and I guess that took 2 night shifts or something like this. And now you can see you have already 6 axes plus all these things where you get here the turnouts and everything. So I do a free cross section or not, no. So this is then how it looks like in this case where we are. So the task for the foreman is now he's got all these axes here, and now he can check and measure from the axis, for example, down here. So it's 44 centimeters, and then he needs to know what kind of sleepers do I have in there and everything. So can we do that or not? So, and then that's where he has to shout, hey, that's working or not working. So the data handling for this W Plus machine is very different than we have for the excavators, for example, because the machine is working along an axis. So that means he's selecting an axis and then he goes there and run that stuff there. And this is also why we have all these different axes in here, and as well all the different surfaces here. But actually we have a workaround now here because we decided to put everything in one model, but depending on how we designed the software, you only grab the axis and the software grabs directly the models to it as well. So another challenge, as you can see, that's only a small list of my projects. I have a project in Zofingen, which is already done. And that was the first model which was done. And there we had this context, especially that the surface didn't fit. So if I go here and show the cross section in here, you can see here it looks fine in this case, but moving forward, hang on. If we go here, for example, then you see these jumps here, and they are not allowed here in Switzerland. So the model needs to be changed, and it would have been worse. Before it was this model on the left hand moved over more to the right, and this one moved over. So this is already the second version we did. So as well, you can see now the known points here. For example, if I go, oops, sorry. If I go here, we get the information. Okay, that's one of the fixed points. Its name, it's 33 because it's the mast 33. So you have all these points in there. And because of the code 305, we know that it's one of the masts, as an example. So at the end, what we did, we changed the axis to proper land XML axis. And I remove also the model here and take this one. And now also if we go here and check the model, it looks then as well different. So I haven't selected any axis. And also if I go in here, oops. So you can see what happened now in here, but you can see it's now very smooth in here. This is how it has to go as well for the machines, because the machines which are running afterwards, the tempering machine, they also need to have proper surface beforehand they can go. So last but not least, that's all the normal gauge systems. I'd like to show you how Luzern looks like, which is now the big project we are doing, and just received some data yesterday. So that's the central station here, and yeah, it's nice there because you have the lake directly beside, but you don't have time to go there. So that's all our known points. I can show you now, we have some parts here. That part is already prepared, but yeah, needs to be cleaned as well. And as well now, yesterday I just received some data for that part, and if I switch that one off again. In this case, we are not responsible for the data, so that's done by external people, but you can see already we have these different layers overlapping, and we have only one axis inside. So we need to get a cleanup of all these data now, and I need to talk to these guys here. So this is how it looks like. So, and now you have to imagine the foreman has to think, okay, that's my axis, that's my offset, and I have different surfaces underneath. And I just learned yesterday by this project in this part here, completely they have 4 different or 5 different profiles, depending if it's normal gauge, standard gauge, if it's on a turnout, which turnouts, which sleepers are done, and so on. So that are the most of the things of the challenge. So I'd like always to come to the end of my presentation. So, and sometimes, yeah, this is how job sites look like here in Switzerland, but I imagine in Scandinavia it's similar. So, but this happened just overnight from Easter Monday, they had plus 15 degrees, and the next morning it was -7 with that snow. Yeah, first, so I'd like to thank you for everybody. Please feel free to ask questions, and yeah, thank you. And sometimes we are allowed to have job sites where others do vacation, so sometimes you can enjoy that as well.
Thanks, Katja. That was wonderful presentation. Now we have a time for the questions. So let's see. Hokkanen has asked here. So what is the biggest benefit for the rail maintenance contractor in digital site process?
Yeah, it's actually, we observed the issue actually about the data itself. And that's actually the thing where we are going onwards now, and as also SBB, for example, is aware of that they produce not proper data. And also SBB has decided now to go forward, and they also founded the BIM department there. So the market is changing everything. So, and the benefit is, okay, the data is getting better and better. And as I mentioned, actually nobody knows what is below our rail. Is there only ballast, or is there somewhere cables running which nobody knows of, for example, and then you're into that. So that's the challenge for the next years, to get proper data and build them as well. So, and actually, therefore, Infrakit is the easy tool for us, that they can check also models.
Okay, thank you very much. Now we have another question. So how easy and how quickly did you master Infrakit? So
what do you mean master?
Master means that how easily did you get it in use? How easily people get to know it and started to use it?
It's still ongoing, I have to say, because I was aware of Infrakit before, So, but I've never used it in that deep detail, and still we are struggling on some issues, I have to say. But yeah, we get the support from Infrakit, and yeah, we are learning as well. So, and we are going to optimize as well our workflows depending on that, what we can do with Infrakit, for example. And I have to say as well, we only are using a small part of Infrakit, yeah, so far. But I decided, okay, we want to go small steps, not the big step in the beginning where everybody gets confused. And for sure, in the beginning now, still we are babysitting all our foremans on the job sites, which is
yeah.
But for me, it was very easy. Put it like this,
So did I understand right that you are at the same time also developing your processes?
Yes, or influencing them, put it like this, because I'm talking to the modelers each day, put it like this, for example,
Yeah. So then we have a third question. Could you tell us about as-built data collection? So how you import it to Infrakit?
That's a little bit different. It's depending on our workflow we have on the different job sites. So we can collect them either with a machine, then you can see them directly in Infrakit. And we have the second thing is that we use our surveying equipment where we just measure directly in the model. But our approach is, I have to say, not at the moment. We are not checking the as-built data in Infrakit, only roughly when we got them in there. But at the end, we have to produce a heat map where they can see directly on the colors, depending, are we below, are we too high, what's the issue, can we go for that or not? Because in our contracts, normally we have, I suppose in every contract, you have to fulfill the accuracy at a certain stage.
Okay.
So,
okay.
And
just interested, do you do it on real time, or how the process is?
No, it's going afterwards. And you have to imagine we have a night shift. You're not doing this on the fly.
Yeah. Okay, then we have a fourth question. How much time and effort do you save by having machines connected to Infrakit, meaning send models and receive as-builts?
We haven't done so far any research on that because actually the challenge we have is about this. Most of the things are running on these small projects. It will change during this Luzern project where we have the machines running for a longer time, which means for weeks and months, which is not normally on these small turnout projects where we only have one night shift. And so that will be reviewed in the future.
Okay. Thank you very much. Do we have any other questions? Let's see. Looks
Ilkka
like
has written something. What kind of quality documentation do you generate and collect during the construction other than as-builts? For sure, we take a lot of pictures. That's the main thing. On stuff.
Okay. And waiting for other questions. It was so good presentation that people are really satisfied. So there is not too many questions.
Yeah, I guess I only can show now pictures with nice surfaces and machines and other scenes.
Okay. But if there ain't more questions, we thank you. Big hand for Katja from Sersa Group. And we go for another presentation. So thank you very much, Katja.
Yeah, thank you.
Thank you. And next presentation comes from Leica. And as you might have heard, we've just released our next generation integration with Leica. connecting all devices like MC1 machine control systems and Captivate professional survey kits. And what does this mean? In action, this means that there is a seamless data flow from all Leica devices to Infrakit. Please welcome Sales Manager Ronald de Ronde from Leica. Please, Ronald, you can start.
Thank you very much. I had to think about the title of my presentation, and I was thinking about a book written by Ken Older, and it's called The Measure of All Things. And I don't recommend to read the book because it was really boring, but it was the content was very interesting. It was about two astronomers in the French Revolution period who were measuring the size of the world. And they wanted to do this because they thought that the size of the world was becoming the standard for the meter. So they started doing this, and they took 7 years to measure from the polar up to the equator what the distance was. And from there, they said 1/10 of a million, that will be the meter. And that's the meter, the standard we're still using. And yeah, I was a little bit triggered by that one, because what we do nowadays, that we put easy systems on an excavator where our operators can do exactly the same job they did, but done with the tip of a bucket. So then we make life a little bit easier, and we measure maybe even more accurate than those guys did in those days, and that in a few minutes instead of 7 years. My name is Ronald. I'm responsible for sales and support in Leica Geosystems in the Netherlands. And yeah, the previous presentation from Katja, I know her because she first trained me on using icon and machine control years ago. So that was more than 15 years ago that I started in machine control. Leica is a big company, but it is owned by the company Hexagon. Hexagon is a worldwide organization focusing on measuring technology. And here you see where the focus is sensor solutions. So we make a lot of sensors where Leica is most predominant. We focus on autonomous solutions and software solutions. And all of that have all to do something with data or measurement of data. And there you see what's happening over time, that we see that the data creation, so the way we collect data, is going much faster than the data usage. And I think where Hexagon is focusing on, but also Infrakit is focusing on, that we are closing this gap between data creation and data usage. We're trying to improve the usage of the data, so we're not just collecting data, but also use it. Leica is a very old organization. Here you see some history parts. So basically it started with Kern, that's a long time ago. But yeah, Leica itself is originated from Wield. And as you see, it is established in 1921, which means this year we're celebrating Leica's 100 years existing. So it will be a big party by the end of this month. And Hexagon is a little bit younger, but today we are pretty big. If you see the numbers, it's worldwide more than 21,000 employees, and where Leica is one of the biggest working companies with around 4,000 people. And me, for the Benelux, I have around 65 colleagues, where some of them are in sales, but a lot of them are in support. I'm first starting to focus a little bit on the products. We produce quite a lot of products which are used all in machine control or heavy construction environment. First of all, the most easy ones, which you see, you can buy on the website from a lot of shops, is the digital products. It's a measuring tool which is used for measuring distances or setting out. So it's a lot used in building and construction. Then I think one of the most known, the Captivate solutions, where surveyors around the world are using. which our most interesting one is the GS18i nowadays, the newest one, where you not only can measure, you can also tilt the pole, but you can also take images, which you can use to collect data and measure later on in the pictures. Then we have a lot of scanning operations. So the P40 is our main, the one which has the longest reach, but the fastest one is the RTC360, which measures more than 2 million points a second. And the smallest one is our BOK 360. It's really a small one, it's around 15 centimeters high. Then we come to the mobile solutions. Of course, the drones are very much used in earthworks, but also the Pegasus systems you see on the left, I come later to that one, is used very often to measure the progress on job sites. And then we have the icon line. Katja in the previous presentation also showed that they're using the icon line to use in the roadworks to measure points, to set out and stake out points. And then, she mentioned also about cables we didn't know under the ground. Well, we have some very nice solutions for that on. So that's cable detection and ground penetrating radar systems. Then we have, of course, the lasers, from lasers for rotating, lasers for just horizontal, or pipe lasers if you're building sewers. And of course, the heavy construction machine control equipment, which you also saw on some of the machines from Katja. And this all is combined in us under one dome, which is called heavy construction. If we go first to the machines, I think the most interesting part is that we have one docking station that fits on all type of machines. And on that docking station, we have one panel. That panel can be used also on. Sorry, my telephone was ringing. That panel can be used on all types of machines and running all the same software, which means we can have excavators running with the MC1 software. We can have dozers running with the same kind of software, and you can easily change the panel from one machine to the other one, and it's automatically recovering all the settings from the docking station. So even if it's a new panel, it automatically retracts all the settings and calibration stuff from the panel itself. So all this type of machines, and you see here the wheel loader, which is not commonly used around the world for excavating, but in the Netherlands and Sweden, the wheel loader is more and more used instead of a grader. So it's a very common machine in our earthworks. And then the piler, the drillers, but also asphalt machines and the skid steers, as Katja also showed. What do we install in an excavator? Well, first of all, we install sensors, and these sensors they are all having not only measuring the angle but also the accelerations to correct for sudden movements and stuff like that. On top of that, we have the docking station we put on the panel, and we have a GPS positioning, but it can also be a total station if you want, to have the global position of the machine. And here we have a small video where we already installing it. Unfortunately, no sound for you. But here you see the whole process, what's happening. So if we get an order, we go install. Nowadays, it's more and more at the location where it's a new machine, where we do it at the dealer itself. So in this case, it's a Cobelco dealer. We put on all the cables, all the sensors. And I think, one of the most important things, if everything is installed, that we also calibrated the machine, so we are sure that we get the accuracy we want, within 1-2 centimeters of the bucket. Here you see they start measuring the system. We do that always with prisms on the machine. We have a special software for that one. It's called the Icon software, but there is a module in there where we can calibrate the machines and get them as accurate as possible. And when we're done, we put a sticker on it. Yeah, okay. Here comes the support. I'll come to that later on. So in the old days, we were doing like this. We had a surveyor staking out all the points, and nowadays we're moving towards having the system on the machine where the operator can see everything he's doing. Yeah, and we don't need a surveyor on the job anymore. It's the same when we go for example, concrete. In the old days, we were all putting on strings to set out where they had to go. And the strings are always a lot of work to put up, but they're also a risk because if someone tumbles over it. Yeah. And nowadays, what we try to do is do it with total station, and here it's a one setup, so you can even run it in combination with GPS. And these kind of machines are running now without any string in the field. And that's something this is also put on other. So the same software, the MC1 software, can be used on concrete pavers, can be used on asphalt machines, can be also used on milling machines, where we are running this vertical string lines, which we can make in the office and send them to the machine. And the string lines on this kind of asphalt machines, it's not only used for the height, but you can also use it for the direction of the machine. So it's automatically steering if you have a Vögele machine, and it's also automatically adjusting the screed width. So you can create the model, put it in the machine, and then let it completely run automatically and adjust all the heights. And as you see, you can use it with one mast, but that's only for the smaller machines. But most of the time they're using with two masts. So you have also the direction set. So here they're going to show you that they have a wider setup, more than 6 meters unit, at least two masts for the accuracy. Okay, then we come to the next project, which is called the Pegasus. So if you want to measure, and you want to measure the as-built before, for example, you starting to do any design or new design, or you want to measure as-built, or your clearance of roads or whatever, you can use the Pegasus system. And this one is collecting a lot of data. So it's really megabytes of data. So it's a scanner on board together with cameras, which makes it a completely point cloud, which can be used to measure volumes, to measure, to design, make your design, to see if your design fits in the actual situation. And we have really customers using this on a daily basis where they run over the project to monitor the progress. So to see the volumes, to calculate it from there. So instead of using a drone, you can also use this kind of machines or kits to do this kind of as-built checks. And here it is how it looks like. So on the left side, you see the picture where they measured it, and you see because of the cameras we have, you can collect all the data you have it colorized, and you can measure details inside it. Even though you're driving maybe with your car up to 60-70 kilometers an hour, you can still have accurate position of 1 to 2 centimeters. And that's the absolute position, and relatively, you can even have it better and more accurate. So you can measure cracks in the road to see the size of that one, within being on the road itself. Then we have the underground mapping. So we have the ground penetrating radars. We have different ones, and some of them even the DSX. is made to work together with machine control. So you can measure and see what's in the underground, and then directly use it to upload it to the machine. So if you found a pipe or a cable which has to be protected, you can directly upload it to the machine as an avoidance zone. So yeah, the operator gets a warning the moment he gets in the neighborhood of this machine or this cable. So you can be more careful and not hitting pipes and underground infrastructure. Then we come to the Icon and Captivate lines. So we have two different lines. Captivate is the one is designed for surveyors and is capable of doing everything a surveyor wants, while the Icon line is made for professionals working in building environments and who needs to do measurements. So it's a completely different software running on it, but it is made for people who wants to measure and wants to take out move in building construction or earth moving. And the good thing is both of them can be used together with Infrakit. And now we get a short video with an overview where you see where all is connected together. So we see the excavator running on this model. We can see the GPS where you can use as a base station, where you can use it to measure the points as build point. And all that can be combined later in the office. What is all connecting us? Yeah, so inside Leica we got Connex, and the Connex is our cloud data synchronization system. Yeah, so all the equipment you saw can be used to upload data, and not all of them directly. Some of them you have to be in the office, like the Pegasus. You have, I mean, that data is so huge, you have to work on it. But all from Captivate, all from MC1 systems, everything is connected to Connex. And Connex is our cloud service, where you can upload models, you can visualize models, and you can download models to the machine. And that's what we're showing now in our movie here, the seamless integration. Yeah. So data which is stored on Connex will automatically be synced to the excavator, but can also be synced and downloaded to the field controller and can upload it. So if an operator measures points as an as-built, like he's doing now with his bucket tips, that one is automatically uploaded to the cloud or shared between other machines if you want. And in Infrakit you can use this information, but I can do that later on. And Leica is always using open standards, so we don't have to use the Leica format. We can use LandXML to be uploaded to the machine, and that you're directly working on that one, or you can even use DXF files to work on that directly. And that's from the Captivate, that's from the Icon side, that's from the MC1 system. Okay, so what you see from design up to the maintenance, we can use Connex to connect to our machines. But we also know that on the job site, it's not always Leica. Something we do hope, but it's not always like that. And there, I think Infrakit becomes a major cooperation partner for us. Yeah. Where we see where Connex is just syncing files and downloading, upgrading, Infrakit can do more, and they can also connect others to it. So in the complete workflow, where you see that we have the design we put to the machine or anyone outside, and it can also be the foreman measuring the things. Then we get the as-built data, and that all is collected together, and it's a kind of circle which is going around. Yeah, and that data you can design it and create it in Infrakit, move it to Connex, sync it, and from there it's coming to the machines automatically. And that's what a lot of customers in the Netherlands are doing. For example, Heijmans, a very big contractor in the Netherlands, they're using Infrakit on a daily basis, where they connect machines from not only their own machines, but also from subcontractors, and they're working together. So what you see there, they use it to use auto logging points in the machine. So the operator is trained and forced to measure everything he's doing. And some of them, because they're doing it so often, they ask us to put on special buttons in the joysticks to make the measuring a little bit easier. And all Icon rovers or Captivate rovers, they can be connected to Connex. And from Connex, there is a seamless sync with Infrakit. So there is our cooperation, which is very fine. And here is a little bit the picture how it looks like. So Infrakit will be the main on this kind of projects, where Connex is one of the vendors who is integrated. And from there you go to all the machines up and down. And there I think Infrakit can be a very good solution, especially on the mixed projects, where you have more brands than only Leica. That was it for my presentation. Are there any questions?
Thank you, Ronald. Thank you. It was a really great presentation, and we have two questions here. I have one personally, and then another from headquarters from our product vice president. So let's start from that. So if you think from the customer point of view, which is the most trending Leica technology for 2021, where customer gets the most benefits? So the Leica technology for 2021, customer receiving the most benefits.
That's a little bit depending on the customer. I think if you're a contractor and really working in earthworks, I think you should invest in MC1 systems on your machines. If you're a surveyor, of course you should invest in the Connex connection so you can work together with Infrakit. If you don't have Leica already, but if you do have Leica already, you can just easily make connection Connex, and from there you can cooperate on all these kind of projects together. But I think for now, if you have a contractor and you have machines, invest in MC1 systems for machine control. And if you want to measure progress, I think you should start investing in solutions where you can scan and monitor progress.
Okay, then we have another question. Are you ready?
Yes.
Okay, I showed. So how Icon side is integrated with Infrakit? Does customer need to pay for both subscriptions, like Icon side and Infrakit?
Yes, you need to be able to sync data from Connex. You need a subscription for that one, and from the Infrakit side, you need to have the licenses there. But so every machine who has a Connex integration can be used in Infrakit, but you need the license locally for the Connex connection. Yes.
Yes, and naturally you need the Infrakit platform.
Yes.
Okay, do we have another ones? Anyone from live from here, from Espoo? And as was the previous presentation, this was also so good that there is not too many questions. Most of them was answered already on your presentation. So if there is not more questions, we thank you.
Then I thank you also for having this opportunity to present Leica in Infrakit. And I know we're working very well together, and I hope that will remain for the future.
Yes, the whole Infrakit team is really honored this kind of cooperation. One question popped up in my mind. How do you see personally the digitalization taking over within next 5 years in infra construction?
That's going very fast. If you see the progress from 5 years ago, we're just putting models in the machine, and now on all projects, all machines are measuring. Then I'm 100% sure that if they want to save our planet and save resources and speed up processes, that all companies have to invest in digitalization and BIM processes, also in infrastructure works. So I will see it's going very fast in this way. Yes, that's my expectation.
So you see that it's already now about sustainability, not about just efficiency of the work.
Yeah, it comes hand in hand, luckily. So if you're sustainable, most of the time you're also more efficient. But I think sustainability becomes the major driving force also in this environment. And that's not, you see it also in the engines from stage 4, 5, 6 engines they are forced to. It also comes to saving nitrogen, CO2 exhaustion. And I think digitalization can help speeding up this kind of processes also.
Okay. Now there are coming more questions. Do I understand even the question? There is a question regarding data management through design machine as-built process. Is there any further definitions? Question regarding data management through design machine as-built process.
And what's the question about that one? So what we're doing now is that so Infrakit sends the models to the machine, and all data which is collected in the machine or on the rover, and the machines, that will be automatically uploaded to Connex, and from Connex to the cloud of Infrakit. And from a rover you can manually upload it if you want, or do it automatically. What we see there is that where we first simply logged points, it now becomes also coding data. So you are really measuring and putting information to that one. So the surveyor task will move towards the machine. That's what I think is going to happen. And sooner or later we will start adding pictures also made from the machine to add to this data collection. So the measuring and information collected from machines or rovers outside in the field will become more and more and more. I hope this answers the question.
Yeah. Now we see that the crowd has gone wild, so there's a lot of more questions. Are you ready, Ronald?
Yes, let's try.
Yes. So, question about: can we scan asphalt surface settlement in maintenance period, and what's the tolerance error?
Yes, we can, and the tolerance is a little bit different on what kind of product you're using. So we have different kind of scanners. It's also different purposes, the various scanners. So we have ground penetrating radar, especially for asphalt. Also, if you want to measure things like layers. And we have the Pegasus Ultimate systems, which can get very accurate positions of the height of the asphalt. And of course, we have other scanners like the BLK2Go, which you can use for scanning and measuring. So it's a little bit, depending on the purpose, what you want and what accuracy you want to establish, what kind of product we recommend for that one.
Yes. There is a lot of more questions, but we need to keep the schedule somehow, and we will answer those questions later. We will send the link to email. We are recording also the webinar, so we will answer also those questions later.
Yeah, if you send me the questions, I will email those persons back with the answers if you want.
Okay. So we will do that.
Great.
And now we have 15-minute break, and we continue after 15 minutes. Thanks, Ronald. Thank you, Laura.
You're welcome.
Okay, 15 minutes break. Okay, welcome back. Now we have a next presentation from Ilkka Tieaho, Vice President of Services at Infrakit. He's going to tell us about Infrakit services. Ilkka, please.
Can you hear me?
Yes, we hear you.
Okay, and can you see now a slide which contains digital infra construction webinar topic? Now.
Yes, we see.
Yeah, okay, yeah. So let's get this show on the road. So, okay, thank you. Very nice to see that there's so many people online enjoying this brilliant webinar. Really nice use cases from Katja and Ronald there before me, and I'll continue with my presentation. And the topic is successful deployment of Infrakit and high quality infra projects. So my name is Ilkka Tieaho. I'm the VP of Infrakit Services. So a little bit about me, my background. I started in the early 2000s with ground investigations and surveying. Then I moved to design and consulting. So there I was a project engineer and a designer and a project manager. And then later on, I got interested with BIM and digitalization. I moved to be a development manager, and then 3 years worked as head of development in Sitowise, large design and consulting firm with 1,500 people working there. And then I joined Infrakit, and during the past 10 years, my responsibilities in projects has always been the implementation and development of digital workflows in design and construction projects. So I've been the project lead and designer and project manager, and then I moved to the other side of the table to develop those processes. And my specialty over the past 8 years, I have led over 80 development and education projects. The theme has always been the same. It has been the BIM and digitalization of infra project and how beneficially use the digitalization in real work as we do it. So the clients have been the contractors, the owners, and design and consulting companies. So that's my background in a nutshell. And then I will tell you the outline of the presentation. First, I will start with our services team here in Infrakit. And secondly, we will have a look to our team's mission. Why do we exist and what's the meaning of all this? Then we gonna introduce you to our services and then our main product with services, which is the Infrakit deployment projects. And this is more the generic stuff, but the thing I think you are the most interested from is the customer cases. What we have done with customers. So there I have a few customer cases and how they beneficially have used Infrakit in their work in real projects. And to sum up and conclude this presentation, at last we have some results and feedback from our customers, how we have helped them and what do they think about our services overall. So about services team, we have, I think the really strong point about our services team is that we really have a very strong competence and experience from the infra design and construction projects. So we all have been working in the field and in the office, and the team has combined over 100 years of experiences from the projects. So we have been working in the projects, and we have different kind of backgrounds, and we have a grasp of the whole life cycle of infra's built environment. And of course, we participate in national and international organizations which are aiming to improve the digitalization and the use of BIM worldwide. So there I'm talking about Building Smart and SEN technical committees, which are reinforcing and improving the use of BIM overall. And what we have done during the past 18 months since I started, we have recruited 9 people, and we have ongoing and done over 50 projects where we have developed customer processes in infra projects. So that's our team. And then the hard question, what is our mission? And to be crystal clear, why do we really exist? And the answer is that our team exists so that we can ensure that our customer succeeds in infra projects. So a smooth transition from there to our services. What kind of services we provide to our customer to develop those processes in infra projects in different roles. So first of all, we got training services, which consist of Infrakit Office training, and then of course our apps, which are used by mobile phone and tablets, Infrakit Field and Truck app. And all of those training are customized per organization and project needs. And then our main product, which is the deployment projects, we always have the 3 different phases, which I will tell you more about in the next slide. So there we start with workshops, then train and orientate the people using Infrakit, and then we provide the expert services for the whole way in the projects. So those are our services, training and deployment projects, and then of course services team is responsible for the Infrakit customer support, and that service is included with the license. So here you see our recipe and our approach, how to deploy Infrakit into your projects when you start. So if you want to go to the full way with us, we always start with workshops for the project. So we go through the initial data of the project. We read through the procurement phase documentation and figure out the different kind of project requirements related to BIM, information management, and quality requirements. From that data, we are able to squeeze the project's key targets And when we have those key targets generated and known with all, we can figure out how Infrakit can be used beneficially in different roles. Because it's not always only the surveying manager or machine operator who uses Infrakit in our projects. It's a whole project personnel. So from that workshop, result is a common project plan, which we follow. The next step is the training and orientation of project personnel and tailor-made trainings with the project personnel. There we really ensure that all of the people using Infrakit have the required know-how and competence so that we can follow the project plan and meet those key targets that we have together figured out. And when the actual construction starts, we of course provide the expert services to the projects. So we like to be there where the work is done, practical level, hands-on services on site and at the office while the construction is being done. So we like to go the whole 9 yards with the customer. And that the project plan, we use this monthly follow-ups, and of course these lean methods, plan, do, study, act model. We steer and measure what we have done, and we document also what we have been able to do and what we have what are the results of our activities. So Infrakit deployment project is combining 3 key elements in infra projects, which is the clear process, the enabling technology, and the people. With those components, you really can get good projects. And the interesting thing is how the project plan, based on our experiences within the 18 months and 50 projects, how we deploy that project plan. And it really is that the project plan has been executed by providing the expertise where the real work is done. So in this slide, for example, you see 6 different pictures, and all of these pictures have been taken from our customer cases. So you can be sitting with the foreman and machine operator figuring out in a construction booth how and in what order will you do your next area. You can be figuring out with the owner, with the lead designer, and with the contractor what we have designed and what is to be built during the next 2 weeks in the design meeting. And it can be that our expert will be on the top of a roller of an excavator, making sure that we have the optimal data flow from Infrakit to machine control systems. And then again, it can be a training session. It can be our expert making sure that the supervisor and foreman knows where the bridge foundations will be built. So we are providing support to real work that has been done in the projects. So now we move on to the customer cases. First, I will talk about a customer city of Vantaa, and I will have a few different perspectives. First, I will go through the use of Infrakit from the perspective of builder, the actual builder. Then I will look at the project's development of construction quality as a whole. And then another customer case, Stara, which is providing construction services in Helsinki city region. We look at how Infrakit was able to enhance the project's collaboration. And as a really background information, really important background information, that these customers had 0 prior experiences with the use of Infrakit before these pilots. So all of these things we show was new to these guys. So the first thing I will show you is how the actual builder was able to use Infrakit beneficially in his work. So we started the deployment project with interviewing the people, and when we were interviewing the actual builders, we found out that they have no digital data for their work available. So there was only paper PDFs, which was quite often out of date, and they had some random emails what they should do. Sometimes final design plans could be on a project bank somewhere. But then together we agreed that we'll use Infrakit Field and provide these actual builders all relevant data for their work through Infrakit. So all information was available with handheld devices. So in this case, I mean the final design plans, the DWGs, the PDF files, the XML files, which means the infrastructure information models. And this information was used in the builders' work so that they can do their work properly. So they were using this information while they were operating and doing the construction at the bottom of the pit. So there we really were able to enhance the project's information management, and we were able to make sure that these builders has a effective construction process and they do the construction right for the first from the first time. So these are sceneries from the Infrakit field. So this is the scenery, the project's information from your tablet, from your mobile phone, and this is a map view. This is a cross-section view. So in the next slide, we have here illustrates the scenery from Infrakit. So for example, how you can detect and visualize these final design plans in Infrakit. You would need to have these DWGs as a builder, and then you would have these, for example, these well cards as PDF files, which are final design plans. So next, I'll jump into our platform. I'll log in to the project, and then I will start showcasing a few things. So for example, here you can see the vehicles, but that's not important. What is important is I've saved a few views here. So this is the scenery for the foreman, for example. He knows that this is the, for example, this is the storm water well number 153, and these are the directions and elevations of the different pipelines leaving from this this well. And lots of pictures were taken there. And this was the vector files that the actual builder could use on site. And of course, he would have the PDF files here in files page. I will click to that same well information, what can be found from the well cards. So I just downloaded this PDF file here from Infrakit, and now we got the same thing on a digitized paper. So well number 153, what's the diameter, what's the material, what are the different elevation points of the structures, what are the directions of the pipelines going in and going out from the well. So this being said, they really got all the relevant information for them to do their job. So this is the scenery from Infrakit office. For example, the project manager or the foreman could see it this way from the computer. And this is the scenery from Infrakit Field, which is the mobile device app. You can use it with mobile phone or tablet, and you can open up this exactly same information for you to do your job in a high quality manner. Okay, and then we continue with overall quality. Furthermore, we discussed with the project personnel, what about the photos? photos weren't always taken, and if those photos were taken, those photos were in on mobile device or email. And now the new way is that we can share the taken photos with everyone in Infrakit platform, because as we all know, one picture says more than 1,000 words. So next I will show you a few photos from the site, what the actual builders have taken. As I log back into Infrakit map page and then look at the same views, I have, for example, this. We left with this situation. The actual builder knows where the well is. He knows the direction of the pipelines, and when he has done the construction, he can even document it, because this is what the owner requires in this project. So here you can see really the situation. The well has been installed, the pipeline is there, the final filling is there, the filter fabric is there. So it's kind of nice that you take pictures of things you have built, because those pictures make the owner often happy. And you can even take this 360 degrees picture of where you really can see in 360 view what's the situation status on site. So here we can see, for example, some district heating cables, filter fabrics, and this is a pipeline conduit trench. And here we have some rock needs to be blasted, and maybe some stormwater excavation here, or culvert and logistics of this. This is, if I see correctly, this is sewage well there, and there's some clay and silt which definitely needs some supporting for the excavation. So these kind of things you can see from these pictures. And once again, while we were conducting this way, we enhanced the information management, because these photos were required by the owner. We got all of these photos in one platform for all the use, and we were generating this quality documentation as we do the construction. So it was very effective workflow. So no need for extra phase when doing the digital handover at the end of the project. And then next we got fleet management. So prior to this pilot, the city of Vantaa did not have a machine control system used, and no common data platform for this machinery. At times when they used machine control, they handled the data management with USB sticks, which is not the best way. So the new way was they could share the common real-time data with all machinery. So I will show you the vehicles page here in Infrakit. For example, here you can just click the vehicle and check the rights. For example, here toteutusmallit means machine control models in Finnish, and we can see, okay, this machinery has the insulation structures, the drainage systems, the culverts, the embankments, the sub-base cores, the base cores, and so on. And for example, this other machine only has embankments, and it's doing the phase of construction, which is reduced weight embankments. So we can share the needed data with all machinery, and it enables high quality because all the machines has the right data and up-to-date data for them to do their job. An effective workflow, because there is high risk of getting things wrong when we are using USB sticks. Those surveying guys do not have fast enough feet to keep all of those machinery up to date. Then some more quality stuff. So about this grader as-built points taken with total station technology, Leica MC1, points from unbound base course from grader to Infrakit. So the old way was that no as-built points or as-builts were, if they were taken, they were sent by email to project bank. So now we have all relevant and agree as-built points, part of quality documentation in one very visual platform. I will showcase you the asphalt points next. So here, unbound base course with asphalt points. I can get rid of the background map so it's more clear. So this kind of job the grader did, and we can have a free cross section from here and check how the structures were actually built. So when we have selected the asphalt points from the unbound course structure, we have the asphalt also. So we have all quality documentation in map, in cross section, and I will showcase you real quickly how it can be seen in 3D view. For example, here I have this one saved view, and what you see here is all the information models that the machinery commonly shares here in Infrakit. And here you can see also the asphalt points. So very visual view to all quality documentation. And for this, for example, this case, the grader did this unbound base course. And here we got some excavation done by GNSS technology. Okay, I need to hurry up a little bit. It's 23 minutes done. So this means while we are using this kind of processes, we got better quality management, better situational awareness of the progress at site. We know where things have been done. And again, thinking about the quality handover material, we really have an effective workflow because we are generating the quality document as we do the construction itself. So then this is the 3D picture which I showed you guys. So the next slide is how to enhance the project collaboration by utilizing standardized processes and Infrakit inside meetings. So in this case, the owner and supervisor and the contractor agreed on a process. They will share the site meeting agenda in Infrakit platform week beforehand the meeting, and then Stara as a contractor can add related info from work phase report to the agenda. And when all the actors were in the site meeting, the contractor, the designer, the builder, and the supervisor were all on the site meeting, we went through topic by topic, and the project engineer showed the status from Infrakit in a very visual way, giving insight topic by topic. So I will show you this from Infrakit also. I will just switch the project to a right one. So here we got Herttoniemi project, which is a project which is conducted with Stara as a development project. So here we got all the side meetings. Here we can see that, for example, 10th of March, the project engineer showed 7 kind of different topics in the side meetings. So all have a crystal clear understanding of what's the status of the site. And here I saved 2 views. So for example, here we have a deviation from the plans. We had a side meeting in 10th of March, and before the side meeting, the project engineer went on the site, taking a few pictures. For example, here, this added work, of course, because the design thought that the rock surface should be far below, but now it's really in the surface, so it needs to be blasted. So this is the way that the project engineer communicated this deviation to all project parties. And this is a second picture from the same situation. There is rock that was unexpected, and there is some special arrangements that had to be done with water pipeline and joint structures there. And the second use case is like district heating done in 19th of March. What's the work phase and what's the status? So the actual builder, once again, took a really nice picture which tells us what we are doing there. So here's a really long description about the work being done here in Finnish, but this means that the district heating pipeline is being under construction and the filling is done with stone ash. And here we can see in the picture filter fabrics below the pipeline, and then the final filling will be done with the stone ash as well. And the work phase was conducted by Leo Riikonen, Eero Hanninen, who took the picture, and then there is a machine operator from the subcontractor. So this kind of information, even the actual builders can report from the site. Now I have only a few minutes, so I really need to speed up. I would have this other example of star collaboration also. I will give you only this one. They have all the relevant information in Infrakit. As you can see, the list of documentation here. But what they did and found very useful was that they used Infrakit, standardized processes, and new technology, which was the drone and 360 camera. So this was used inside meetings and were found very, very beneficial when going through the different work phases and what's the status of the construction site. You can clearly, this is quite small site, so you can really see everything that is happening on the site at the moment. Okay, I have to jump back to my presentation. And now, to get back from where I started, what is our mission? Our mission was to ensure that our customer succeeds in projects, and based on our experiences with the customer so far, the mission is implemented by providing the expertise where the real work is done once again. So that is the recipe for us all to succeed. And these actions will lead us to having successful infra project in the end. So I think this way, the customer will get the full potential out of Infrakit, and the customer will have very productive design and construction processes and effective data flow between data, technology, and people. And the customer's projects will be on time and under the budget. We can be productive in a sustainable way. And you can find some case studies from our website behind the blog. There is lots of case studies where we have achieved things on time and under the budget. Some feedbacks from the customers, for example, the City of Vantaa, Director of Construction, said that they really had solid first steps to develop organization culture and digitize infra construction, and they thought that they get really good concrete results right away when they started the use of Infrakit. And they expanded with 4 new pilot projects this year. And then the other one coming from Stara Construction Services project engineer, just in a nutshell said that Infrakit was a very useful platform and everybody is aware of project needs and progress at all times. So this can really enhance the collaboration between the different parties of the project. And finally, some net promoter score that we have had some clients responding in the past 18 months. So responses has been 103, and the satisfaction in deployment projects, the net promoter score has been 100%. And with training services, it has been 72%. So how likely you would recommend Infrakit services to your colleague? Sorry all, I went a little bit further than I should have with the timeline, but thank you all for patience and listening. Now, do you have any questions, or do we actually have even time for questions? For more information, just contact me. Thank you.
Thank you, Ilkka. We could listen to you for hours, so don't mind about the schedule. We record this and send also to those who have need to leave the meeting webinar. We have a question here, actually. So it goes like this. Can we add laboratory tests in PDF, geolocated as we can do with the photos to see them and on as-built models?
Yeah, you definitely can. It's not a big thing. And if you need to do it, you can just contact me and you see the information there, and we can go through the scenario.
Okay, so you can attach at any documents, PDFs, files, whatsoever.
With shell reference, yeah.
Yeah. Okay. That was the question, and then we go to the next presentation. Thank you very much, Ilkka.
Thank you.
And next, Tõnis Vään, 3D Business Area Manager from GRK Infra Estonia, is going to tell us about project Tallinn-Tartu 4-lane motorway. And Tõnis, I've learned myself some Estonian. I'm going to try it now, so palun alusta, please start.
Okay. Hello to everybody again. My name is Tõnis Vään. I work for GRK Infra, and my everyday job is to manage and equip from office GRK Infra construction sites with correct 3D models. If I want to do that quickly and efficiently, it is important to find the good tools which can improve your work. That's one of the main reasons why I started to use such a common data environment like Infrakit. So today I'm going to give a brief overview, one of GRK Infra objects where we are using Infrakit. The object is, as you can see on picture, Tallinn-Tartu new 4-lane motorway. And to introduce object, I will show a little video. As you know, video can tell more than 1,000 words. As you can see, the construction area is in the middle of Estonia. Here you can see about 16-kilometer long main road start and end. It has 5 main junctions and many smaller structures. Here you can see overview of those areas. There are 3 main road viaducts, 2 bridges, and 1 animal overpass, what you can see right now. And on the picture you can see current situation. Main road junctions are in 2 levels. Here you see the biggest Anna intersection. Of course, there are a lot of smaller structures like noise barriers, ponds, local and pedestrian roads, and so on. I'm not going to talk today about all these technical details. I have chosen some of the bigger areas. So let's take now a closer look on Puiatu animal overpass, how it looks, and what we do in Infrakit, and how it looks on construction site. As you see right now on Infrakit map view, it is really easy to get a quick overview of site. You see there are combined design 2D drawings with 3D models and reality situation by using orthophoto underneath. If we click on a model, we can see quickly the model name and 2D area. Also, we can do our freehand cross sections wherever we need. turn on all surface models and take a closer look on situation. On cross-section, it is really easy to see all models. Take different measures and also check absolute level and slope. On map view, you can also look all the pictures that have been made by object team, say using cell phones with Infrakit app, sometimes also drones. To understand better how 3D models look and to check are they correct, we use 3D visualization tool. This tool also helps to create the situation when the design models and existing ground model are turned on. And here you can see the reality of construction site. There's going to be 2 concrete arcs, and if I remember correctly, then on top of these arcs going to be about 10,000 cubic meters of material. To finish this Pujate animal overpass, the total amount of earthworks are over 200,000 cubic meters. So let's take now a closer look on third main junction called Anna. On map view again, the same. We see how 2D drawings have been combined with 3D models and reality, using again under these drawings orthophoto. We mostly use 2D drawings to make cross sections on right place, depending on what we want to see on cross section. This is a way how we check does viaduct IFC model and land XML models are coordinated correctly. Taking measurement, absolute heights, slopes, this is basically what we do every day. Here is another cross-section example. Here we can check road asphalt level. Here you can see this blue one is road asphalt level surface, how it connects with viaduct IFC model elevations. Again, and here you can see how we use visualization tool, which gives a good overview if there are any model errors. Here we see designed land XML model and viaduct IFC model. To understand and checking models more accurately, for me it is important to see wireframe of surfaces for detailed geometry. And if we turn on existing ground model, then we see that there needs to be excavated a lot of material. This excavated material is limestone. If anybody noticed before, already on cross sections, the main road surface is going to be in this junction under existing ground. And if we take a look on construction site, so then we can see all this explosion work that needs to be done. It's about 220,000 cubic meters limestone that has to be excavated. actually such a good material to be used because we have many road parts where we have to excavate unsuitable soil and refill this suitable material. And here you can see explosion works. Okay, and here I wanted to show you one main road area where we had to excavate unsuitable soil. If we do cross section, we can see the depth of excavation. When we turn on all models, we can see how it's supposed to look finally, and of course we can take different measures. On construction site, most of the limestone that is excavated from Anna intersection is used as filling material to replace the unsuitable soil areas, which is about 1/3 of all needed backfill material, and all this unsuitable soil is excavated. In total, about 600,000 cubics. And here is again this Anna junction. And here I wanted to show how we can get a quick overview of 3D design and as-built model. These are Anna junction limestone models. The pink one is as-built and yellow is design model. If I want to look more detailed geometry, then we can always do the cross sections and turn on model wireframe. And on the second picture, I show you how you can do a quick check on map. The 3D top model is exactly the same like 2D drawing. These are the slopes and ditches on both sides of main road. We just have to turn on model wireframe again. Of course, person who is looking at must be experienced and worked with 3D models. And here is my conclusion about using Infrakit. Why we are using Infrakit is mainly because we can have a quick and really good overview of object, especially when object is quite big. If it's small, then it's easy to handle with everyday programs. When it's quite big, then it's good to have this Infrakit environment. All project parties are in the same common data environment, like I said. And then they can see at every moment what has happened, what has changed. And also if we upload or download new models, drawings, and everything. Also orthophotos and pictures are a really good material. For project team, also smartphone app helps really good them to position on site and also take a coordinated picture if needed. So thank you everybody. I guess it was quite quick video introduction. If you have some questions, then And also, I will put right now Infrakit on live, and we can check it on live also. Here I can show you, here is starts this new project what we are doing right now. And here on orthophoto you can see previous road section what we built with GRK Infra, and also there was another company. It was about half building GRK Infra and half second company. If we take a closer look, here are these viaducts and junctions. Here's gonna be this Puiatu aqueduct, overpass, animals. Here we had to do a lot of unsuitable soil excavation on this section area. And here is this biggest junction or not junction. And also we can take a look on, again, here is this Võõbu viaduct. I don't have right now here this viaduct IFC model, but the overgoing asphalt model is here. We can take a look some more. This one is Korba viaduct. Here is a small road what goes under it. And here it's going to be, how to call it, it's a vaporing pond. It's a pond and it's supposed to vapor all this water what is going to be inside it. Because here it's coming teachers inside and going outside also. And here we can see two more bridges. This one is main road. This one is this Kükita bridge, and this one is Kruusiaugu bridge. Here we have Pärnu River, what goes on the bridges. And here I have done new models because we have to change little river flow. If I turn on, existing ground model, try to find it. And you can see we have to change this one and off it. Also, if we turn on this wireframe, it is good to take a detailed look. Also, we can see here is old main road, and new one is going here. And here is the ending of the new main road. So thank you very much. And if there are some questions, yeah.
Okay. Okay, Tõnis, we have questions here.
Okay.
So what CAD software do you use to make your 2D, 3D design and export them to Infrakit?
We are using Autodesk Civil 3D mostly.
Civil 3D.
Yeah, Civil 3D is our everyday tool to make models and to handle these 2D drawings.
Okay, and then we have another question. Does your subcontractors also use Infrakit?
Yeah, we have quite a big subcontractor, and I know that they're using also Infrakit to do their everyday work. And of course, they are using also measuring points to check their as-built models and layers.
Okay, and then there is a long question. Let me see. If we have just 2D data plan, profile, and cross-section, how much time professional needs to have 3D model before starting construction?
Okay,
without using any surveying equipment.
Yeah. Actually, this will take time. It depends. Okay, if we have profile with this profile database also, then in Civil 3D it's quite easy to use these corridor models to build up new models. If we have just a plan 2D drawings, then it takes quite much time because you have to insert all these profile heights.
Okay.
Again.
And the question continues, time per kilometer.
It's hard to say. It depends. You just have to look this. Let's take example. If I have to look this new project, what we have there. Do we have only 2D drawings, or we have some 3D drawings, and it depends. A lot of things. I can't say it exactly right now.
Okay. And as I'm a salesperson, did I understand right that it's very simple?
What do you mean?
It was a joke.
Okay.
Shouldn't have done that. I have one personal question because I've been really nervous through the whole webinar. Okay. To our values and to our strategy belongs that we are close to customer. We respect each other, and the partnership is built based on a real cooperation. So was my Estonian correct?
Yeah, it was.
Okay, now I'm really relieved. And Tõnis, I promise to learn more Estonian when I come to next time to Estonia.
Yes, that's good because we are neighbors.
Yes, and it's important for us in strategy as well. So, do we have, Linda, any more questions? Okay, Tõnis, that was the last question. So, thank you very much. It was really good presentation.
Okay, thank you. Bye-bye.
Thank you. Bye-bye. Next, Visa Hokkanen, Vice President of Product at Infrakit, is going to show and tell the Infrakit roadmap for 2021. Visa, please.
Tony, can you hear me?
Yes, we can all hear you. Please, Visa, continue.
Excellent. So let me put on the presentation mode. Okay, good afternoon, good morning, good evening, wherever you're at. My name is Hokkanen, and I'm going to discuss a bit about the Infrakit platform from products perspective. So discussing about roadmap for 2021 and the near-term development. And first, just a few words about myself. So I'm a software engineering from the background. And my previous career, I was actually working with the grade control related things at Novatron. So quite familiar to model-based construction. And then I've also done a bit regarding BIM standardization in Building Smart and in Building Smart Finland chapter specifically. And now I've been working as a product owner at Infrakit Group headquarters since 2019. And my duty here is to bridge customers and development in a way that we can bring value for our customers. And then probably due to my past, I've also been involved to standardization also at Infrakit regarding heavy machinery at ISO TC 127 and also in this IFC 4X3 deployment project in Building Smart. And then I'm also involved a bit on research topics. So if we think about Infrakit as a platform, I know you are all people from the business and you have your own perspective to things. So I trust you can apply a lot of things I say to your daily business and how this may and will help your business and impact through getting like a full site picture in Infrakit platform. And in this picture I try to explain like how we see this business, that we need to import various GIS data and BIM data, so geospatial information and designs like virtual built environment into common cloud platform, so that we could actually visualize that information and deliver and distribute that information further to people and machinery. And then once something is done on site, so it could be like from the first steps in the project when you do some inventory things and do those field trips and document how the ground actually looks, and you could utilize that for your design and maybe also to your bid processes. Infrakit can help you there, and definitely in the construction phase when you can actually share all of that latest and greatest information to people and machinery, and you can actually carry out the work with the latest plans. But also the maintenance. So we have also quite a few use cases where our customers use our platform to distribute maintenance information on site, and it's a lot of these use cases are boiling down to the fact that you have some plans, some virtual replicas that you need to actually accomplish and carry out, and then you have reporting that may be as-built points, that may be photos, it may be PDF templates, and you need to build up the quality documentation about the work on site, and that's really what Infrakit is about. And therefore, we have also adjusted our roadmap accordingly. So we have all of these baskets that we see our platform needs to move towards if you want to be like in this game also next decade and the years after. So we have these baskets: BIM, GIS, applications, integrations, and then we have some platform specific things regarding scalability and performance. So if we can, I think I will just go and drill down each of these topics individually. So if we think about this GIS basket, what we see there like happening, lately we have focused on building up standard interfaces, OGC standards, more specifically WMS, WMTS, to get ortho images, those background maps, raster maps, as building a base for the situational awareness on site. And what we see for the future is that there will be even more of these standard interfaces, like towards city modeling, 3D tiles especially is very interesting. And through those technologies, I believe drones will be integrated even deeper to the process. So in this presentation, I'm bundling drones to the GIS basket, and I have actually a example. This is not on release Infrakit version yet, but this is something soon to come. So for example, when you are building somewhere deep in the cities, like that is one of those trends that people are focusing to live in the cities, and also infrastructure is built in the cities. So it is kind of convenient to make design work and also the construction work so that you can actually make those new designs to meet the 3D reality of the city. And here you can see city of Helsinki as an example. So this is open data available by the city. Then a few words about building information modeling. Of course, Land XML is a great workflow. That is something we can integrate to a lot of field systems like grade control and surveying. But especially if we look into the design sector or design segment, it's something that will take main leaps forward in coming years. So currently we've been focusing on expanding the functionality and making more comprehensive IFC library for like current 2x3 and 4 series IFC models. But what we really look forward for the future is that IFC will actually expand beyond rough concrete structures. So today the case is that wherever you see concrete, it's mostly like IFC stuff, and when you see gravel or sand, it's probably Land XML models. But in the future, IFC will be able to represent a lot of different disciplines. So it will be possible to get full-blown projects in IFC models. And now it is kind of interesting to see this development in Building Smart. They have this IFC 4x3 infra deployment project ongoing, where this new schema is actually tested within the whole industry to see how those road and rail models will be actually delivered from system to another in a standardized way. And that is really something we look for the future, that we get more harmonized models across a lot of different disciplines from different systems, very similar models, and that of course is a really good for our common customers. In the machinery and equipment segment, what we have been really dealing with lately is this new Leica Connex connectivity, and we are actually, the development is not finished. We are continuing still with the Connex stuff to make it even faster and also expanding the functionality. But then together with that, we are also working towards Triple Connect, that is also enabling some more workflows, for example, towards site vision system and also various Trimble design suites. So that is very interesting direction as well. And then we have TopCon SiteLink version 2 in the development pipeline that will offer this new TopCon grade control interface for the TopCon systems. And then of course we have our Infrakit partner API, where we have actually many integrations in the pipeline. So there's new surveying gear coming up, new grade control systems coming up, also some document management, photo management, CD kind of integrations coming up. And what we really look for the future is this heavy machinery standard ISO 15143, where we are actually one of the participating players in the working committee. So that will make these equipment workflows even more convenient and more harmonized. So now the case is that different brands have a little bit of different twist how the interfacing is done. Of course, the main things work pretty similar, but the heavy machinery standard will harmonize the functionality, how interfacing towards machinery will be done, and it's also becoming more comprehensive. It will introduce new stuff like common localization for different brands. Then one perspective is Infrakit apps. This is very important for us because the mobile apps this is the viewport to the information for people. So when you have those workers down in the pit, where they look for the drawings, where they look for the PDF documents and 3D designs, they of course need their own tooling for that, and Field App is our solution for this. So it is possible to visualize the information office people see and machine operators see in your smartphone. And of course, when we are discussing about people, it's UX is the big deal. So we want to make it even more user-friendly and also more tidier. So we will actually have a new UX. We have a new UX design in place that we'll introduce for both iOS and Android platforms in coming times. And same applies for our mass haul solution, Infrakit Truck. So here in the right-hand side picture, you can see the new fresh look of the upcoming truck app. The left-hand side is the Field App screen. Then for the web interface, there we are focusing heavily on two separate topics. One is the project bank functions to enable more search functionalities and better visualization of data. And this also leads to a enhanced collaboration model we've been working on quite a lot lately. And there the focus points have been to improve the controls and also enable huge mega projects to be visualized in a single project. That is not a easy task to do, to get all of that data available in a single browser view, but that is the goal. And I have actually a couple of examples about these apps, like how they've been used and what's the latest deal with that. So first, I have a video where my colleague Mikko is doing some staking out. Field app can be connected to some or any of the third-party RDK sensors, but also together with that, it can be used for photo management and PDF reporting on site. So in this case, Mikko is taking a photo. Some poor guy has lost his helmet, so better report it to the supervisor. Either the helmet is lost or the guy is lost. Anyway, it's something to report. And of course, the beauty of the solution is that it's not only in Mikko's phone now, it's available for the whole team. So you can immediately see in your home office that, okay, we have a problem. We have a guy lost. Let's do something about it. And then another one, speaking about situational awareness. Point clouds. This is one of the improvements from beginning of the year that we have implemented together with our partner Point Scene. We are streaming point clouds, and in this case it is a rock excavation. The green is the model for the excavation, and the gray that looks more like an actual ground, that is outcome of the drone flight. So as you can see here, the blasting has gone pretty well. Not too many spots to hammer out. So we can get nice visual view available for the site foreman and owners and whoever are part of the project. So drones and 3D photos, point clouds are really good way to bring those sites alive. And I think many times you can see better view of the site from your home couch than by entering the pit, when you can see all these plans and actuals combined in the same view. And also something we developed quite recently, we made a little bit more convenient way to look those cross sections of those sites with all the data available with the IFC model, land XML model, and point cloud at one. Okay, then we have some one basket of things is what I call non-functional, something that is not like directly visible for a lot of our customers, but something very crucial to our business. And one is of course the scalability aspect. So we are looking forward to scale to more countries and more continents. So it means that we need to offer our services nearby our customers. So we need a scalability. We've been working on that the past 2 years quite a lot actually. And another aspect is that Infrakit is becoming a part of enterprise architecture of construction companies especially. So think about like the whole ICT tooling and how to actually harmonize your processes in a company. You need to fix some tools and some processes, and once you go there, one crucial thing is the authentication. And one thing we are now working on is the federated identity, so that you could actually use your personal company login to log in to Infrakit as well. That makes it more convenient for ICT managers to keep up when people are coming and going not only to projects but into the company and out of the company. And then third important topic is the performance improvements. That is something we've been noticing, that it is equally important to keep everything up and running as smooth as possible, as running in the front edge of the technology. So we want to ensure that everything is usable and fast as possible to use. It's of course a lot of new features, always nice, but I think it's even nicer to have things you have released run real smooth. So that is something we've been focusing. And as a summary, I have a picture where sort of everything is built up. This is all the strategic things we are now working on. We are developing our platform further. We are making our apps more user-friendly, and we are improving the scalability and performance of our platform. And here you can see the same swimming lines just discussed. Like there will be these standard interfaces towards machinery, towards design suites, towards geospatial information systems. And then there will be always a lot of these proprietary platforms that our common customers use and are very, very much needed to make data available for various technologies. Yeah, and then we have these iOS and Android and web development topics together with those user authentication federation problems, etc. Finally, just some news about the team, how our development team looks today. The team itself is led by our VP of Engineering, Sakari, and our CTO, Matti. And the current team is 13 software experts in Europe. We have around about 10 people in Belgrade, Serbia, and then rest are in Stockholm and Espoo in north of Europe. Latest recruits include Hannu, who came from Spotify to ensure our scalability. Then we have Velko, who has a long history developing IFC products. And George became to ensure our products comprehensive test automation suites, and Dennis started to build up the new UX layouts. And one important topic, I've been really happy about our Infrakit services team, who, of course, the main topic is to help our customers to succeed, but they're also great asset for our development, for policing the customer requirements to really make the best possible features that serve a lot of and work as a solution for a lot of use cases. So I think I've becoming to the end of my presentation. I'm open for any questions. Please don't forget to follow us on LinkedIn. That is one of those social media channels we will post about all new stuff we will publish. Back to you, Tony.
Thanks, Visa. Great presentation. And that was the last presentation. So next we're going to send the recording of this webinar. You can find also it later on from our web pages. Thank you for the great presentation and joining us today. Have a nice day and see you next time. Bye-bye.